Hey, all right, so it's final lecture, spring 2016, and I just went through a little bit of economics lecturing, and now I want to bop back into Moodle Shell, bioenergy, spring 2016, and I'm just going to do a little bit of on-the-fly grading here. Oh yeah, this is, I think, Damien wanted to see that guy. Exam, review. All of these quiz answers are now posted, so you can go and take a look at those. Oh, and let's look at this discussion before we get into too much more grading. Economic trade-offs, carbon credits, 6 days ago. I feel like carbon credits are good things for the economy, but not doing much in the effort to reduce carbon emissions. Interesting, okay. Since carbon credits can be bought and traded in a market scenario, a carbon producer can just buy more credits and produce more carbon. Yeah, it's a good question. And when and what I really don't know about this, you buy them from, well, I'm not sure you're actually buying the credits from somebody who's sequestering the carbon. That's the issue. Let's just go take a look at it.
I think the article I found kind of describes it pretty well.
Okay.
How many millions of dollars do you give us going based on research and reports?
Okay, so I can go in. Okay, so it's $5 for 1,000 kilowatt hours, $6 for 1,000 pounds of carbon, $2 for 1,000 gallons. Okay, so what I'm trying to figure out is where the money actually goes. Let's just take a look. Using carbon calculator, fine, okay. We fund projects that destroy greenhouse gases and produce renewable energy. Okay, there we go. Each project is made possible by your purchase of RECs, or carbon offsets. Okay. So I think this is probably one of the funds that the university was buying into. Gotcha. Farm power. It's a full project list. I like that. Landfill gas capture. Sounds like a good one too. Yeah. Kind of slow, huh? Oh yeah. I don't know. Is that, you think that's the Kevin Dome? Oh, Flathead Valley, gas to energy. Let's learn more. This is good. 1.6 megawatts, that's not a whole lot. This is a little confusing. Expected to provide 1.6 megawatts in 6 years. Is that when it's, by the time it's done?
Yeah, in 6 years they'll get that, or over 6 years?
Yeah, it's not clear. Yeah, yeah. Prevention, surrounding areas. Okay. So really what they're doing is capturing methane. They're still converting it to carbon dioxide. And, well,
isn't that actually better than just leaving the methane though?
I think it is, yeah.
10 times
That's right, it is, yeah, it is.
Lesser of two evils, I guess.
Yeah. Well, gosh, maybe it's time to put our project up on that, up on this guy. It's a good one though, okay.
That's one thing I found out about the wastewater treatment is they use methane to capture and use it on site.
Yeah.
I thought that was pretty cool.
Yeah, it is. No, yeah. Any time you can burn that methane. The one thing that I keep puzzling over, and I might as well draw it out right now when we're talking about it, is this involves my own research, and it even gets us back to chapter 2 of this course. Is, let's say we have this is a great thermodynamics problem, and I'm sure it's been answered before, but let's just say this is your fire in here, and of course you've got hydrocarbons going in, CX, HX, woody biomass, methane, propane, what have you. You also have O2 going in, and then nitrogen going in. Now, as we know, you can get two different things come out. You can get work coming out, or you can get heat coming out. So work is W, heat is Q, in terms of energy, but you're also getting emissions. So CO2, H2O, NOx, etc. The question is, can you take this work? You're never going to, the heat's just going to be there. The heat's always going to come out. The question is, can you take this work and run a pump to basically bottle it? So is there enough work coming out of the system to drive a pump to recondense all of that, all of those emissions? I'm pretty sure the answer is no. Because, coming in, you've got, so just looking at energy flow here, you've got chemical, here you've got thermal. More than likely your pump is going to be electrical, electromechanical. And then at the end of the day, you're basically putting it back into mechanical energy, so, pressurized energy. So maybe in the next iteration of this course, we'll try to solve that thermodynamically, but it's something to consider. Can you actually make enough electricity to simply sequester all these gases that you don't want into the atmosphere? Because I'm sure in that Kalispell landfill, they're still emitting CO2. Something's going to leak out. Okay, lots of good carbon credits.
Sounds pretty good.
Oh, yeah, BBC, okay. Russia and the Ukraine had lower standards. Yeah, there's no agreed to international governance. Keep tabs.
I guess what it means, there's not really anybody overseeing it, really.
No, there's just a bunch of disjointed markets.
Really.
Sure. Oh, some countries went as far as just to create the chemicals.
They would make them and then they would destroy it.
Yeah,
The carbon credit they could sell for money.
right.
So the article kind of mainly talked about how it completely backfired, trying this, more of the emissions were created.
Yeah.
Just trying to get the money.
Mm-hmm.
Instead of
Yeah.
money.
Yeah.
But that's the article itself there.
That's a tough one. Okay.
I usually like BBC stuff, they're usually pretty,
Yeah, they're pretty on the ball. Pretty on the ball.
a little better than Fox News.
Everyone's good.
Unless you want to watch the Trump show, then Fox News is perfect.
Oh, shoot. Okay. Bonus, looks like I got one other unread poster. Let's just take a look at that. Ryman Schneider, okay. Forest Restoration Initiative, goals to structure. I like that. I might take that to the governor's office in the Southwest. Yes, I know it's happening in bits and pieces in Montana, but, well, good. So it is the USDA Forest Service. I'm always baffled why the Forest Service is under the USDA instead of the other way around. It's just, I don't know. Anyway, fire adapted ecosystem. So. For forests.
Do you know if we actually have more agricultural versus forests? Do you know what that ratio is?
In Montana,
Just
I think there's a lot more forest than ag in Montana.
Montana, more countrywide.
Oh, you know what? I don't know the answer to that.
I didn't know if it was that way because there's more agricultural versus forest now, where it used to be probably the other.
I should know the answer to that because I just got done reading a couple of books. One was called The End of Plenty, and it just talks about how much of the Earth's surface has been farmed, and it's pretty astonishing. You know, it's a, and I don't know the numbers off the top of my head. But I also finished reading Dick Manning's book called Against the Grain, where he kind of talks about the shift in sort of irresponsible practices in agriculture from his opinion. But yeah, it sounds like a lot of the agricultural lands from the eastern U.S. have kind of, some of them just gone back to forest. You know, in a lot of ways, it's not a bad thing if you're building soils and want to have sustainable practices.
Because we're actually using good soil. Productive soil, I guess, is pretty fast, actually. Can't remember the
Yeah. Okay, well, there's a good chunk of land. This seems a little strange to me that you have these prescribed burns. You know, again, it's a little bit like it's surprising to me that this is a better solution than using that wood for energy, compost, etc. I don't know. I scratch my head every time I see that.
But it's so fun how we
Well, big bonfires are fun, you know.
But yeah, you think there could even be like a portable burning system that you could bring on site, and of course then you got to store the energy somehow, which is still one of the bigger problems, I guess. I don't know.
There's people doing, making biochar, which is a good, viable agricultural product. So you don't get rid of it, you just convert it. All right, I'm going to take a break here too, and then I'm just going to do just a little bit of grading right at the end.